In the following guide, we'll be exploring the top 18 basic database interview questions and answers. This resource is designed to help you prepare effectively for your upcoming interviews in the field of database management. We will be focusing on both conceptual and practical questions to provide a comprehensive understanding of essential database topics. Whether you're a beginner or an experienced professional, this guide is sure to be beneficial for your interview preparation. 1. What is a database? Explain its purpose and importance. A database is an organized collection of data stored and accessed electronically. It serves the primary purpose of managing and organizing data efficiently. In a business or organization, a database plays a critical role in storing information such as customer details, sales transactions, product inventory, and other business-related data. Its importance lies in its ability to provide a structured and systematic way of storing, retrieving, and managing data. It enhances data consistency, reduces data redundancy, and improves data integrity. A well-designed database also enables users to access and update data quickly and accurately, which helps in decision-making and strategic planning. Without a database, managing and handling vast amounts of data would be a complex and time-consuming process. 2. Define DBMS and explain how it differs from a traditional file system. A database management system, DBMS, is a software that interacts with the user, applications, and the database itself to capture and analyze data. The DBMS software additionally encompasses the core facilities provided to administer the database. The sum total of the database, the DBMS, and the associated applications can be referred to as a database system. Contrarily, a traditional file system is a method for storing and organizing computer files and the data they contain to make it easy to find and access them. In essence, DBMS provides a more sophisticated way to store, retrieve, and manage data as compared to a traditional file system. For instance, in a file system, if we want to search for a particular record, then all the files need to be traversed. However, in DBMS, we can directly fetch the record using a query. Additionally, DBMS also provides additional benefits like security, backup and recovery, concurrency control, etc., which are not available in the traditional file system. 3. What are the main components of a database system? A database system primarily consists of 4 components: data, hardware, software, and users. Data. This is the most crucial aspect of any database system. It can be in various forms, such as text, numbers, images, etc., and is organized in a meaningful way for easy access and manipulation. Hardware. These are the physical devices that store the data. It includes servers, hard drives, networking components, etc. Software. This includes the DBMS, database management system, and the operating system that manages and controls the hardware and provides a way to interact with the data. Users. These can be people or other software systems that interact with the database. They can be database administrators, developers, or end users who use the application. Each of these components plays a vital role in the functioning of a database system, and their interplay ensures the efficient management of data. 4. Explain the difference between data and information. Data refers to raw, unprocessed, and unorganized facts or details without any context. It can exist in any form, usable or not. It is just characters, text, or numbers which are not processed and have no relevance or purpose. On the other hand, information is data that has been processed, organized, structured, or interpreted in a certain context to make it meaningful and useful. It is the value derived from the data after analyzing it. Information helps in decision-making as it is processed data that has some meaning. For example, numbers in a list can be considered as data, but if these numbers represent scores of students in a class, then it becomes information. Data is often collected with an intention to create meaningful information that can be used for various purposes. The process of transforming data into information is carried out through technological, analytical, or logical means. One important thing to note is that information is always derived from data, but data does not always have to come from information. 5. What is a relational database? How does it differ from other types of databases? A relational database is a type of database that organizes data into tables, with each table consisting of rows and columns. Each row in a table represents a record, which is a set of related data. Each column in a table represents a specific attribute of the data. A key factor that separates relational databases from other types of databases is the ability to link or connect data from different tables through the use of keys. This ability to establish relationships between tables enables the efficient and accurate retrieval of data. Unlike hierarchical or network databases, relational databases have a flexible structure that allows changes to be made to the data structure without needing to modify all the existing records. Relational databases are structured, making them highly organized and efficient. They work best with structured data and are powerful in handling large amounts of data. They can also maintain data integrity and can prevent data redundancy. However, they might not be as effective when dealing with unstructured or semi-structured data, such as images, videos, or text documents. For handling such data, NoSQL databases or object-oriented databases might be more suitable. They are designed to handle data that doesn't fit neatly into tables. 6. What is normalization? Explain the first three normal forms. Normalization is a systematic approach of decomposing tables to eliminate data redundancy and undesirable characteristics like insertion, update, and delete anomalies. It is a multi-step process that puts data into tabular form by removing duplicated data from the relation tables. The first normal form, 1NF, sets the fundamental rules for an organized database. Eliminate duplicative columns from the same table, create separate tables for each group of related data, and identify each set of related data with a primary key. The second normal form, 2NF, further addresses the concept of removing duplicative data. Meet all the rules of the first normal form and remove subsets of data that apply to multiple rows of a table and place them in separate tables. The third normal form, 3NF, goes one step further. Meet all the rules of the second normal form, remove columns that are not dependent upon the primary key. Normalization is fundamentally about structuring data in a way that aids retrieval and helps to avoid anomalies and redundancies. The first three normal forms are foundational in achieving these goals. The first normal form, 1NF, focuses on ensuring each table cell has a single value, eliminating repeating groups of data. The second normal form, 2NF, takes this further by ensuring that all non-key attributes are fully functional dependent on the primary key, which can mean dividing a table into two or more tables and defining relationships between them. The third normal form, 3NF, ensures that non-key attributes are dependent on the primary key, not on other non-key attributes, which can mean further dividing tables. 7. Define primary key and foreign key. How are they used in database design? A primary key is a column or a set of columns in a table that uniquely identifies each row in that table. It must contain unique values and cannot be null. It is used to maintain integrity of the data and to facilitate efficient search and retrieval of data. A foreign key, on the other hand, is a field in a table that is a primary key in another table. It is used to establish and enforce a link between the data in two tables. It helps to prevent actions that would destroy links between tables. In database design, primary and foreign keys play a crucial role. They ensure consistency and integrity of data. The primary key is used to identify each record uniquely in a table, while the foreign key is used to prevent certain actions that would destroy the relationship between two tables. 8. What is an entity relationship diagram, ERD? How is it useful in database design? An entity relationship diagram, ERD, is a conceptual representation of data that defines how data is related within a database. It utilizes various symbols to represent the entities, relationships, and attributes in a database. An ERD is an essential part of database design as it provides a visual map of the database structure, making it easier to understand the relationships between the different data points. It aids in identifying potential problems, redundancies, or inefficiencies early in the design process, allowing for adjustments before the implementation of the database. The ERD also serves as a valuable communication tool between database designers and stakeholders, ensuring everyone has a clear understanding of the database structure and function. 9. Explain the concept of data integrity and its importance in databases. Data integrity refers to the accuracy, consistency, and reliability of data stored in a database. It's a critical aspect to the design, implementation, and usage of any system which stores, processes, or retrieves data. In other words, it's about protecting the data from corruption. Data integrity is important in databases as it ensures that the data is real, accurate, and reliable. It helps in maintaining the quality of data across the database and protects the data from corruption, modification, or unauthorized access. Without data integrity, decisions made based on this data could be flawed, leading to potential disaster for businesses. For example, imagine a bank that has inaccurate data. This could lead to customers being charged incorrect amounts or transfers being sent to the wrong accounts, a clear disaster. So, ensuring data integrity is not just a good idea, but a necessity. It's ensured via a range of measures, including data validation, to prevent incorrect data entry, data verification, double-checking data, and use of error detection and correction software. With these measures, the integrity of data is safeguarded, ensuring it can be trusted and relied upon. 10. What is denormalization? When might you use it? Denormalization is a strategy used in database design to enhance the performance of the database read operations. This is often done at the cost of increasing redundancy and complexity of data, by combining two or more tables into a single one. You might choose to use denormalization when the performance of your database read operations is critical and you're willing to sacrifice some write performance, data integrity, and storage space to achieve this. It is also beneficial if you have a large number of complex join operations, as denormalization can reduce the need for these joins. However, it's important to remember that denormalization should only be applied after carefully considering its impact on your particular database system and its requirements. 11. What is SQL? What are its main components? SQL, an acronym for Structured Query Language, is a standard language for managing data held in a relational database management system, DBMS. SQL is utilized to communicate with databases and can be effectively used to create, retrieve, update, or delete database records. The main components of SQL are 1. Data Definition Language, DDL. This includes commands like create, alter, drop, which are utilized to define or alter the structure of database objects. 2. Data Manipulation Language, DML. These are commands like select, insert, update, delete, which are used to manipulate the data within objects of a database. 3. Data Control Language, DCL. Commands like grant, revoke fall under this category, which are used to control the access to data stored in a database. 4. Transaction Control Language, TCL. Commands like commit, rollback are used to manage transactions within a database. SQL is a powerful tool that, when utilized correctly, can manage vast amounts of data efficiently. It is a crucial skill for anyone working within a data-related field. 12. Explain the difference between DDL, DML, and DCL commands. DDL refers to Data Definition Language. These commands are used to define and manage the structure of the database, such as create, alter, and drop. DML, or Data Manipulation Language, involves commands that manipulate data within the database. Examples include select, insert, update, and delete. DCL, which stands for Data Control Language, regulates the permissions and access to the database. Grant and revoke are examples of DCL commands. While DDL focuses on the structure of the database, DML is concerned with the data within the database. DCL, on the other hand, controls who can access and manipulate this data. Data Definition Language, DDL, is primarily concerned with the structure of the database. It allows you to create, alter, or delete database objects such as tables and views. For instance, if you wanted to create a new table in your database, you would use a DDL command. Data Manipulation Language, DML, allows you to manipulate the data within the database. This includes inserting new data, updating existing data, or deleting data. For example, if you wanted to add a new record to your table, you would use a DML command. Data Control Language, DCL, is used to control access to the data within the database. It allows you to grant or revoke permissions to users. For instance, if you wanted to give a user permission to view a specific table, you would use a DCL command. Thus, each type of command plays a critical role in database management and operation. 13. What is the purpose of the select statement? Provide a basic example. The select statement is utilized in SQL to fetch data from a database. It allows you to retrieve one or multiple records from one or more tables in a database. In essence, the select statement is the cornerstone of any data retrieval operation within a database. A basic example of a select statement is as follows. Select column 1, column 2, from table_name. In this example, column 1 and column 2 are the names of the columns you want to fetch data from. Table_name is the name of the table where the columns exist. The select statement's purpose in SQL is to pick particular data from the database. It is a crucial component of SQL and is used extensively in data retrieval operations. It enables the user to specify the data he or she wants from the database, be it from a single table or multiple tables. A simple example would be, select name, age from students. In this, we are extracting the name and age columns from the students table. This command will return a table containing names and ages of all students in the database. 14. How do you insert data into a table using SQL? To insert data into a SQL table, the insert into command is used. This command adds new rows of data to a table in the database. The syntax for this command is as follows. Insert into table_name, column 1, column 2, column 3. Values, value 1, value 2, value 3. Here, table_name is the name of the table where you want to insert data. Column 1, column 2, column 3 are names of the columns in the table. Value 1, value 2, value 3 are values that you want to insert into these columns respectively. For example, if you want to insert a new employee's data into an employees table, you might use a command like this. Insert into employees, first name, last name, email, values, John Doe, john.doe@example.com. This command inserts a new row into the employees table, with John as the first name, Doe as the last name, and john.doe@example.com as the email. To insert data into a SQL table, one uses the insert into statement. This is followed by the name of the table, then in brackets, you list the columns you want to insert data into. After the values keyword, you list the data corresponding to the columns in the same order. For example, if there's a table named students, with columns first name, last name, and age, and you want to add a student named John Doe, who is 15 years old, you would write insert into students, first name, last name, age, values, John Doe, 15. That will add a new row to the students table with the provided values. 15. Explain the difference between inner join and left join. An inner join and a left join are both types of joins used in SQL to combine rows from two or more tables based on a related column between them. However, they operate differently. An inner join returns only the rows where there is a match in both tables being joined. In other words, it retrieves records that have matching values in both tables. On the other hand, a left join returns all the rows from the left table, and the matched rows from the right table. If there is no match, the result of the right side will contain null. Thus, a left join can be considered as giving more priority to the first, or left, table, and it includes all records from the left table whether there is a matching entry in the right table or not. In a relational database, the use of inner join or left join depends on the specific data retrieval needs. Hence, understanding their differences is essential for effective database management and operations. 16. What is a transaction? Explain ACID properties. A transaction in database terminology refers to a single logical operation that is performed on a database. This could comprise of multiple different tasks, but the key aspect to remember is that a transaction is treated as one single unit. Either all tasks are performed successfully or none at all. ACID is an acronym that stands for atomicity, consistency, isolation, and durability. These are the properties that ensure reliable processing in a database system. Atomicity refers to the all or nothing concept mentioned before. If a transaction is made up of multiple tasks, all tasks must be completed successfully for the transaction to be considered successful. If even one task fails, the entire transaction fails and the database remains unchanged. Consistency ensures that a transaction brings the database from one valid state to another. The transaction in itself might be complex, leading to intermediate states that violate consistency. However, when all is done, the database should be left in a state that abides by all rules and constraints. Isolation ensures that concurrent transactions result in a system state that would be obtained if transactions were executed serially, i.e., one after the other. Durability guarantees that once a transaction has been committed, it will remain so, even in the event of power loss, crashes, or errors. 17. What is an index? How does it improve database performance? An index in database systems functions similar to an index in a book. It's a data structure that improves the speed of data retrieval operations on a database table at the cost of additional writes and storage space. By creating an index on a database, it can quickly locate the data without having to search every row in a database table every time a database table is accessed. Indexes can be created using one or more columns, providing the basis for both rapid random lookups and efficient access of ordered records. The more records the table has, the more significant the impact on the performance of the database. Hence, an index can dramatically enhance the database's overall speed and performance. 18. Explain the concept of database backup and recovery. Database backup and recovery refers to the strategies and processes involved in protecting your database against data loss and reconstructing the data if loss occurs. The term backup refers to making copies of data so these additional copies can be used to restore the original data after a data loss event. On the other hand, recovery refers to the process of restoring data to a state that was previously known. This process is crucial as it helps to protect the database against data loss, to keep the system running when the system crashes, and to keep business processes running in case of software or hardware failure. With a proper backup and recovery strategy in place, you can ensure business continuity even in the face of a disaster. This not only saves time and money, but also helps maintain your organization's reputation and customer trust. We hope you have gained confidence and are now ready to ace the interview. If you enjoyed the video and found it useful, please hit the like button and don't forget to subscribe to our channel for more such educational content. Wishing you all the best for your future endeavors.